Okay, we're going to talk a little bit here about some special instances here on circles. This is a little experiment that says pick 4 random points on this circle and connect the dots, making a quadrilateral. We just studied quadrilaterals, so I chose 4 random locations around, and I drew in a quadrilateral. I don't know if it is anything in particular. Maybe it's kind of like a trapezoid. Either way, when you put a quadrilateral on a circle or you inscribe it in a circle, there's one special thing that happens, and that's what we're about to discover. So we're going to look at these inscribed angles. So remember, though, this inscribed angle right here, it still is inscribed. It opens up from here to here. And so I can count 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. That means that's 160 degrees because these are 10 degrees apart. So that means this is 80. Okay. And if we continue to work our way around here, this one, it may be the same. That's 20. 20, so that's 200 degrees. So that means half of 200 would be 100. All right. And if I continue to work my way around this circle, if I count from here to here, this one, I believe, is also 200. That's 20. So that's half of 200 is 100. And then this one right here, which is opens up from here all the way around to here. That's 16. It's 100. So these are the same. Okay, so there was an example right there of something that happens. Maybe it's not the best example that I chose because my dots, my points I chose ended up being the same on each of these. But I'm just going to tell you the relationship right here that's going to happen on all of these is that in an inscribed quadrilateral, these opposite angles are going to be supplementary. Those two are going to equal 180 and those two are going to equal 180. And they're not always going to be the same as each other. So what I mean by that, for example, like if this was 110, this over here is going to have to end up being 70. Like it could work out that way. As a matter of fact, this is a problem right here that you can prove this because I could say that from X's point of view, that this arc right here would have to be 2x because it's inscribed. All right. Which also means this arc, the rest of the circle from here to here all the way around, would have to be 360 minus 2x. All right. Which also means that this inscribed angle that opens up to that blue arc would have to be half of that. So what is half of that? What is half of 360 minus 2x? If I divide it by 2 and just simplify this, well, that would be 180 minus x. So here's another proof of this, that this angle right over here is 180 minus whatever that one is. So there's another way to prove that these opposite angles in a quadrilateral are going to be supplementary. That's the rule. That's the thing. Again, this is all based on or a result of inscribed angles. So once again, we have found another special case or special property that's based on inscribed angles. We haven't really got away from this idea yet. All right. It's pretty easy to use. It says find angle C. It's across from there. It's 80. All right. Find angle A or either one of them. The one across, you have to add up to 180. So that would be 90 and that would be 110. That's the rule. It's very easy to use and very easy to do. So there's a few problems here that deal with inscribed quadrilaterals. They do get a little more complex as you go, but you're still using that base rule. Here's one where you're going to draw it in, but it gives you, these are still inscribed quadrilaterals. Now that one's got a 180 thing dealing with it, but the inscribed quadrilateral rule still works. You know, for example, this angle over here across from 140 is going to have to be 40 right? Because those two you have to add up to 180, and maybe that'll help lead you to some other stuff. Okay. But again, the inscribed quadrilateral rule still works. Opposite angles are supplementary. You could also set up equations. Those two equal each other. Those two equal each other. Or no, equal 180. I'm sorry. They sum to equal 180, sum to equal 180, sum to equal 180. You're going to have to do a little bit of algebra there. That's it. That's the inscribed quadrilateral rule.